Hi guys! In this tutorial, we're going to learn how to create a web API using Visual Studio Code, especially without database. To learn this, install Visual Studio Code IDE, C# Dev Kit for VS Code, and .NET SDK version 9 in your machine. I have provided direct links in the description to install those. Please check. Let's start. Open C Drive. We're going to create simple CRUD services for managing products. Create folder named Product API. Open that folder and then click Terminal to open Terminal. Now, check whether .NET is installed in VS Code. Type .NET version. Yeah, we are using version 9 of .NET Core. Type the .NET command as follows. Create a web API with controllers in it. Name the API as product-API. The web API template was created successfully. Now check all the installed files and controllers of Product API. Let's run the project. Navigate to the project path. Type cd project name, that is, Product API. Then to run the project, type .NET run. Now copy the localhost URL and paste it on Chrome. Type Swagger to it to load Swagger page. Oops! We forget to configure Swagger in program CS file. Enable Swagger in middleware app.useswagger. Error denotes there's no assembly reference. To use Swagger, install Swagger NuGet package. Open Terminal to install the package. Type .NET add package swashbuckle ASP.NET. This installs Swashbuckle, a powerful tool that adds Swagger or OpenAPI support to your project, making it easy to auto-generate API documentation. It tests endpoints right from the browser and also share API contracts with front-end devs. Once installed, add builder services add SwaggerGen to programmed CS file. Also, enable UI with app.useswagger and app.useswaggerUI. Check the code once and run the code using the command .NET run. Visit localhost URL with /swagger in your browser to explore your API interactively. Yeah, it's working fine. Now, create the necessary files to work. Add product controller to the controllers folder. A controller is a C# class, which acts as the brain of your API, controlling how data is processed, returned, created, updated, or deleted. Then create folder named data and add a file to it called appdbcontext to hold the data. Then add a model folder, add a product entity to it. These classes represent the objects that your application works with. In product CS file, first declare namespace. This is used to organize the code. Then Create a class with public access specifier. Inside the class, declare the properties: ID, product name, and price, each with get and set accessors. Get, set, automatically creates getters and setters. String.empty ensures that product name is not null by default. Let's code app DB_context class, which is the main YEF core class to manage database operations. Declare, using statements to import necessary namespaces. Product_API.models gives access to the product model. Then declare class. App DB_context is a database context, and it inherits from DB_context. We should install YEF core package to use it. It acts as a bridge between your C# code and the database, placed under a data namespace and folder to keep things organized. Then declare constructor, which receives DB_context options from dependency injection. Now, install Microsoft Entity Framework core package. Then, install Microsoft Entity Framework Core in-memory package. It is a lightweight, in-memory database provider for YEF core, which helps to seed data easily during development. Import the Entity Framework Core package with using keyword in AppDB_context class. Then, constructor receives DB_context options from dependency injection. It passes those options to the base DB_context class. Then, create a table representation for the product model to query the products. dbSetProduct tells YEF core to create, or manage, a table called products. Use this property in code to query or save products. Now write a overridden method on model creating to customize the model building process. This is how YEF core sets up the database schema and data. Let's learn how to set data without database. Use hasData method to seed the database. It pre-populates the products table with 2 entries. Product 1, laptop. Product 2, mouse. Also set ID and price to it. This acts as an in-memory database to the application. These will be inserted automatically when the database is created for the first time. We should configure it properly in program.cs file, using ensureCreated, method, or migrations. Now, let's configure this in program.cs file. First, register the DB context with an in-memory database products using options method of DB context. This keeps everything in RAM, perfect for testing and development. Then we create a new scope, which is a temporary container for resolving services. This is needed to use appdb context before the app fully runs. Then inside the scope, we ask the service provider to give us the appdb context, the class that manages our database operations. Finally, we call ensureCreated method to automatically create the in-memory database and run any seeding logic from on-model creating. This seeds data to our application. So, our data is ready to go when the app starts. Let's start to write the controller logic. We start by importing necessary namespaces. Declare product controller class that inherits from controller base, perfect for web APIs that return JSON. Then we declare a private read-only variable named _context of type appdb context. This will store a reference to our database context, allowing the controller to access and manage the database. Then declare route API/controller means this controller handles routes like /API/products. Then declare API controller, which gives automatic validation and helpful HTTP behavior. We inject our appdb context via controller, so this controller can talk to the database. Then mention HTTP get attribute. We are going to code to return all products from the database using toListAsync. The method is asynchronous and returns an action result containing a list of product objects. We use toListAsync to fetch all product records from the database asynchronously. Then declare another HTTP get attribute. This endpoint responds to get and return results based on ID. This method is also asynchronous and returns an action result containing a list of product objects. It looks up a product by its ID using findAsync. If no product is found, it returns a 404 not found response. Otherwise, it returns the product data as JSON. Then declare HTTP post attribute. This method responds to post/API/products. It receives a product object from the request body. This is also an asynchronous method and returns an action result. We add it to the database using _context, products, add product. Then we call save changes async to save it. Finally, We return a 201 created response using created@action, which includes the location of the new product and the product data. Then declare HTTP put attribute. This endpoint handles update based on ID to update a product. Pass the ID as an argument to the parameter of the class. First, it checks if the ID in the URL matches the product's ID. If they don't match, it returns 400 bad request. Then, it marks the product as modified in the database context using entity state. After saving the changes, it returns 204 no content, meaning the update was successful, but there's nothing to return. Then declare HTTP delete attribute. This method listens for delete requests based on ID for products. It looks up the product by its ID using findAsync. If the product isn't found, it returns a 404 not found. Otherwise, it removes the product and saves the changes to the database. Finally, it returns 204 no content, meaning the delete was successful. Import the namespace of project's model class. Now run the project. We are getting errors. Let us resolve that. We missed to add one .NET package, ASP.NET Core.MVC. Let's add that, because it's showing missing namespace or assembly reference for HTTP GET, PUT, POST attributes. Wait for a few seconds. Add missing imports too in the controller class. That is, include YEF core and our project's data and model classes. Again, save and run the code. Still, it's showing some errors. Let us check line number on which it is showing error and resolve. It's line number 18 and 20. It's a spelling mistake. Rectify it. Then again run the code. Check the URL on browser with Swagger added to it. Our code works fine. Shows all the endpoints. Let's test the code. Get products endpoint returns all the details of the product we seeded. Then check the product details based on ID. It shows details of the product with ID 1. That is laptop. Check ID 2 also. Next, check put endpoint. Type ID number and response body with any changes to check whether it's updating or not. Let us change the price of laptop. It's showing 204 response, which comes under the result of success HTTP status code. Yeah, it updated the price successfully. Then check delete endpoint. Enter product ID to delete. Then check post endpoint. Type ID, product name, and price, and click execute. Showing 201 HTTP status code that represents created. Check get products endpoint once to know whether it's added. Yeah, it's added. And by the way, all the endpoints we coded are working fine. Hope you learned how to create a web API without database in Visual Studio Code. If you find this video useful, please like, share, and subscribe .NET Core Insights.